All right, I'm going to start up. We've got two things that we're going to go over today. First, I'm going to continue on with this handout that I gave you the other day on MySQL. We're going to do that till about 10 o'clock. Then I'm going to get back to tests. All right, after that. So we're going to go over those from 10 to about 11:50. If we get done early, not a problem. All right. So I do want to mention, you probably know this, and I even sent you an email on this, but if you do go out to YouTube and you type in Jeff Scott, Rankin Technical College, you get to my YouTube channel, and there's a lot more than 75 lists out there. But if you come over here and you go to databases, it's up to 42 videos that I have on databases. And the last 9 were all on this handout right here. Okay, including what we did the other day and what we're going to do today. So that's all out there. It's not complete yet. What I have done is I've gone over all of part 2 on those videos. For now, I'm skipping part 3, and I did all of part 4. All right, we're going to go through everything that's in here, but we're not going to do it in the same order that the authors of this thing put it in. All right, so that's first thing. Just a couple other things. So this is that URL. You've got that. I gave you a copy of that. Okay, so that shouldn't be any kind of issue. But I do want to mention a couple of other things here as we go through. Now, some of this stuff I've gone over with you already, but I want to say it again. We're talking about, for now, MySQL. In about 2 weeks or so, we're going to get into SQL Server. Both MySQL and SQL Server are examples of what are called RDBMSs, Relational Database Management Systems. All right? And more than anything else, what an RDBMS does is it allows you to do inserts, updates, and deletes. I mean, there's other things that it does too, but by and large, these are the most important 3 things of a relational database management system, just so you know that. All right? So the second word in RDBMS is database. So what's a database? We've talked about this before. A database is one or more related tables. So far, we've got a very simple database that's called products. It's called Southwind. That very simple database called Southwind has one table in it. That one table is called products. All right, so that's what we've done so far. That one table that we have in there has got about 6 records in it. All right, there were like 2 or 3 records for pens, 2 or 3 records for pencils. Each one of those records has about 5 or 6 fields in it. So each record has a product code, a product ID, a product code, a name, a quantity, and a price. Maybe I'm missing one, but I don't think I am. All right? And each one of those fields is made up of characters. So for instance, the product ID field is made up of integer characters, so it's numbers. And if you remember, we hard-coded the first product ID in there as 1001, and every one that we put in after that just adds 1 to that. All right, and what's a character? Basically, it's any character that can or potentially can represent data. All right, so there's a couple more on here. So what's data? All right, data is anything that may or may not make sense to anyone viewing it. All right, now I heard yesterday at the job fair, among other things, I heard Mr. Williams here talking to our vice president, and he asked him what he does and where he works. All right, and Brady, hopefully it's okay I say this, he works at a bank. All right, now what I'm about to say, I know you don't do this, but let's assume so much of this stuff is automated today, but I give this example because I think people can identify with it. So let's assume that you're a teller at a bank, any of you, it doesn't matter. And let's assume at the end of the day that what you have to do, and again, I realize that this would basically be done by a computer, but let's just say you have to manually input every single deposit that you have had for the day. Does that make sense? So every time anybody comes up to you, Amin comes in, gives you $100 and says, put this into my account. So later on in the day, you've got to put that 100 in there. All right? Well, if let's say Brady's doing that, he's got, over the day, he's got 100 different deposits. And he types in 100, hits enter, 150, hits enter, 75, hits enter, etc. All right? And Valerie is Brady's boss. So she comes in and looks at it. That list of numbers that he has there, unless he tells her what it is, she might have no idea what that is. Does that make sense? So data may or may not make sense. It usually depends on who's viewing it. Now let's say that it's the end of the day and Brady now has put in all of those deposits, hits enter, and it creates a report. And now Valerie can look at that report, and that report says deposits basically taken in by Brady Williams today. And she can look at it, and now it's in a nice format. That's information. So what a computer system does is it translates the data that's input into a system, it processes that data, and it outputs information. I mean, that's what it's all about. So data may or may not make sense to who's ever looking at it, depending on what it is. Information should make sense to anybody who can view it, as long as you can read. A little kid's not going to be able to probably tell what that is. All right. One of the things that we're going to talk about today is a primary key. My definition for a primary key is not the same as what's in your handout. I like to give you as simple a definition as possible when I can. So this is as simple a definition as I've ever seen for a primary key. A primary key is a unique record identifier. Okay? Now, my guess is, correct me if I'm wrong, I know when I applied here, among other things, they needed me to give my social security number. And my guess is, with all of you, when you applied here, they made you give your social security number at some time or another on a form or someplace else. All right? And is that how they use what they use to track you? It's yes and no. And I know that's a dumb thing to say, but technically you all have a rank and ID number. That rank and ID number, and I don't know what it is. Let's assume here that Colin's rank and ID number is 1, 2, 3, 4, 5. Let's just say that it is. I don't care if it is or not. The point is that number 1, 2, 3, 4, 5, if somebody gets a hold of that number, there's probably not very much they can do with it. Would you agree with that? There's probably not very much they'd want to do with it. But on the other hand, let's assume that Colin's social security number is 111-22-3333. If somebody gets a hold of that social security number, there are potentially bad things they can do with it. All right, they can try to open up accounts. They can try to do all sorts of stuff. Personal information. A social security number is intelligible. That means if somebody gets your social security number, they can figure out information about you. Your rank and ID number is unintelligible. Does the distinction make sense? So if something is unintelligible, it doesn't make sense to most people. If something is intelligible, it does make sense to most people. The reason I'm telling you that is almost always the primary key you'll have in every table that you create will be an ID. And it won't be a social security number. It'll be something like ID, which probably won't make a lot of sense to most people. They don't care because it's unintelligible. All right? So kind of keep that stuff in mind. Bring that up later if we have to, but I don't think we'll have to. All right. The other thing is, and I think we talked about this before, but I'm saying it again anyway. We're talking about two different types of commands right here. We are talking about what are called DDL, or data definition language commands, and DML, which are called database manipulation commands. The DDL commands, they work with the database schema. What's the schema? We looked at this a little bit in the past, But again, if I come in here and I start up MySQL and I bring up the Southwind database, all right, and I say describe products, that's schema. That's data about the data. So that says that this particular table has 5 fields in it. Out of those 5 fields, 2 are integer fields. One is a fixed length character field. One is a variable length character field, and one is a decimal field. None of them allow nulls. This one's a primary key, so again, it can't be null. This one is an auto increment. The default for quantity is 0. The default for price is 99999.99. That is all schema information. So if I want to change any of that stuff that you see right there, any of that, then in order to change it, I have to use these commands. So those commands, the DDL commands, allow you to manipulate the database schema. On the other hand, after we created the table, we came in and we put data into it. All right? Now, if we want to be able to manipulate that data, now what we have to do is we have to use these commands. And out of those commands that are right there, most of them are fairly intuitive. If I want to add new data, it's an insert. If I want to modify existing data, it's an update. If I want to remove existing data, it's a delete. All right? If I want to look at data but not be allowed to change it, it's a select. Those are things that are just going to have to make sense to you. All right? If you get a job where you're doing work with SQL, all right, it's going to be expected. You know what DDL is and what DML is. Could you be asked that at an interview? Possibly. I don't know. All right. But this is all stuff that you should know, you should understand. It should just basically make sense to you. Right. Okay. So what we have done is we went through some of these commands. By now, you should all have, at least for lack of better words, a comfort level with everything that's here. You've done every single thing that's in blue at least once. That allows you to what? Remove a database, create a database, show the existing databases, make a database active, and show what your active database is. So every single command you see there in blue should make sense to you. And if it doesn't, you're going to have to ask. Again, what I did in those YouTube things is I went over the same stuff we went over, but I did it much slower. So if you're having a hard time grasping it, you're going to have to go back and watch those. All right? Then we got into the table stuff. And in particular, we looked at this stuff. Actually, I can go a little further. We looked at that. So you should now understand how to remove a table. That's the drop command. Again, drop table, followed by the name of the table. All right, that's a DDL command. Create table, that's another DDL command. All right, show and describe tables. Now, we really didn't look at these, at the alter table very much. But as you probably guess, alter table, let's assume that when I created these fields, okay, let's just assume I didn't do this, but let's assume that when I did this, I forgot to put in the price field. I just forgot about it. I can say alter table, add column, price, and tell it that, for example, it's a decimal 7.2. So I'm not going to hit enter here. If I start any line like this with a minus, that's a comment. And what you'll see is a lot of times in the tapes that I've been doing, I started with a minus because I could put stuff in there, hit enter, and not worry about it running. All right. So I could come in here and say alter table, products, add column, price, and then say that basically it's decimal. I think this is the right syntax. I could be wrong, but it's something similar to this. Oop, I don't want to put, I want the minus minus again.
What's minus?
The minus minus means it's a comment. It means it's, if I leave the minus minus off, it's going to try to do this. Putting a minus minus there is like putting a comment in your code. It's just, it's skipped. So I want to add column here, and I'd want to add price, and I'd want to say that it's a decimal 7.2. Whoops, 7.2. All right, it's either that or it's very similar to that. But alter allows you to change something that currently exists. All right. We also came in here and we did a bunch of this stuff. We did these insert intos. That's how we added data into the tables. Okay? So it was insert, and we looked at a bunch of ways of doing it. Using all nulls, using a null for our primary key, etc. So you looked at a bunch of examples of that. I very quickly, because this was at the end of the class, talk to you about the delete and update. We're going to look at those some more today. All right? And we looked at the select in a lot of detail. We got through the order by and the limit. We didn't really look at the group by. We're going to look at that today too. But what I'm telling you is by the end of the day, all of that stuff that you see there should make sense to you. If it doesn't, you'll have to go back and you'll either have to look at the tapes, or if you go, oh, I don't have time for that. Okay, you can always go out to dev.mysql.com. All right, that's the MySQL site right there. Okay, that's it. And if you go out and let's say, okay, do I have to do that? Well, you can also say MySQL, and I believe that 5.7 is the newest version, reference manual. And that's going to point you out to the dev MySQL, but that literally right there, so this has literally got everything in it that's MySQL. So if I say something and you forget it, or you don't understand it, or it doesn't make sense to you, you can always go out to the reference manual and find that information, because they give it to you in a lot more depth and breadth of coverage than I'm giving it to you. Not always, but quite often, they also give you examples. All right? And some of the stuff, here's a surprise. The version before 5.7 was 5.6. Okay? Sometimes, if something did not change in between versions 5.6 and 5.7, you might not find it in the 5.7 reference manual. You might have to go back and look in the 5.6. I don't know why they do that, but they do. All right. So, again, you should understand what show databases is. You should have an understanding now when you take a look here that we created the Southwind database. We added the products table, which had these 5 fields, which had originally these 5 records. So there should be nothing on the screen that's right here that surprises you and that you don't understand. All right? What you're going to start doing by the end of next week is you're going to create, I'm going to tell you what's in it, but you're going to basically create your own database. All right? So, create a database. You can just say create. You can just say drop. You can say create and only do it if it does not exist. All right? Drop only if it does not exist. Okay? Again, a couple people asked about this the other day. Basically anything that you do in here, you can't undo. All right? Are there exceptions? Yeah, and I'll show you those, just not right now. Okay? All right. We did this show create database, so if you want to see what the command is, that's no big thing. I think I talked about this, but in case I didn't, if you look up on the top of your keyboard in the very upper left-hand corner, you should see your escape key. And right underneath your escape key, you've got a key that's a tilde. It's, you know, that little squiggly thing. And underneath that, there's what's called a backtick. It's sometimes called a grave accent. All right. When you create a field, so let's say I wanted to create a table, and I typed in create table, and yeah, I'm a little vain, so I want to call it Jeff's table. And I put a blank space right there. You think that's going to work? No. Because it sees the Jeffs and it says, okay, then it sees the table and it doesn't have any idea what that is. But if for some reason I want to put a blank space in there, you can do it. If you surround this with those grave accents. Now that's not recommended that you do that, but you can do it. Again, you shouldn't do it, but you can do it. All right? And that's usually why those grave accents are used. Okay? That there's other reasons that you might use them. But what happens is when you create something, and I don't know if it's even still here, I think it is. All right? See how the system internally puts in those grave accents for you. I didn't put any of those in, but the system does, and it does it as a protective measure for you. Okay? All right. Comments we just mentioned. You can use like we've been using the slash star and the star slash, but for single comments, we're used to using slash slash, but in this language, it's minus minus. All right? The use, by now you should understand that what the use does is it makes your database active. All right? You can use it. It becomes the active database. All right. We created tables. You know, we already did that with databases. And then we created tables. This line that's right here, not line, but these lines, this right here, that should make sense now to all of you. Again, if it doesn't, go back and watch those tapes. This is allowing us to do what? It is a DDL command because it's create. Create what? Create a table. But only create it if one by the name of products, does not currently exist. All right? The delimiter that we use for creating this, beginning paren, ending paren. These are our 5 fields: product ID, product code, name, quantity, price. Those are the 5 fields. And then this says that this first field will be a primary key. All right? You should understand the data types. Int unsigned means that it's a whole number, can't be negative, and it literally has a range of 0 through like 4 billion something. Plenty big. Char means fixed length, so it's going to be exactly 3 characters in length. And technically, it means the system is expecting you to put 3 characters in there. Varchar means variable character length. So in this case, it means it expects the name to be between 1 and 30 characters. All right? Quantity another. Whole number between 0 and 4 billion plus, so no negative numbers. Price, we talked about this. That's how many total digits. So 7, so the biggest number would be 9999999. But the last 2 come after the decimal place. So the biggest number is 99999.99. That should make sense to you. All right? We did the show tables. This line that you see, the describe, which can also be done with just DESC, that shows you the table schema. All right? I've already gone over that, so I'm not going to mention it again. If you need more explanations on the different data types, that's right here. There are many more data types than what are shown here. Again, as I've shown you before, if I come in here and, for example, type in MySQL data types, one of the first hits, if not the first one, is going to be the reference manual. And there it is. All right? And it's got there's 12 data types. So if you want more, you can look through here and notice there's numeric, There's date and time, there's string, etc. And there's other ones. All right, so if you wanted to learn more, and I'm not saying you do, but if you did, that would be a way to do so. All right, then we went in and we inserted rows into the database. And we saw different ways of doing it. Here we just say values, so it expected every field. Here we said values, but instead of adding a value for the primary key, we put null so that the auto increment could take over. Here we only put 4 of our 5 fields, so we left out the primary key. Here we only put in 2 of our fields, so the other 3 were filled in by default values. And here we used null, so everything was filled in with a default value. That should make sense to you. All right? The select star, again, that will show you all of the table information. Normally, it will give it to you in primary key order. You now know what a primary key is. All right. Does this command right here, I'm asking you this, because we sort of talked about it, but we sort of didn't. If you look at the command on your screen that's in blue, does it make sense looking at that command that what that command will do will be to remove the last record that you have in the table? Does that make sense? If we left the where clause out, so if we just said delete from products, semicolon, and hit enter, all right, what's going to happen? It's going to remove all records. Today on the tapes, I made fun of myself. I don't ever mind doing that, but I did an update and I forgot to do a where, so I changed everything. And I said, okay, so now just so you can see what happens when you do this, so I manually went back and changed every one, and I taped that too. All right? But again, there's no magical undo command in here. That's why if you're about to make major changes to a database, think about this. If I work for a company, let's say I work for an insurance company. Let's say it's a big insurance company out of St. Louis. All right? And we've got a database because we've got thousands of customers. We're probably going to have software that's automatically going to back up that database with all of our customers at least once an hour. That makes sense? That way, if it goes down, the worst thing that's happened is, we've lost those changes for the last hour. Now think about Amazon, because Amazon's getting hit from all over the world. In 1 hour, they have millions of things that are happening. They may very well back up their database once a minute. The more important the data, the more often you're going to back it up. All right? If Amin has a mom and pop site, so he's got a small company, and he has 1 customer right now, all right, because he just started, he might be able to back it up once a week or once a day. But as his business grows, he will back it up more often. We're going to start talking about backups, not today, but we will discuss backups too. All right. So again, it's delete from. Delete is a data manipulation language command. So you don't have to say what you're deleting. If we were dropping it, we'd say drop table products. But we're saying delete from the products table where the product ID equals 6. Now, this may not sound important, but what I'm about to tell you, to me, is one of the most important things in today's lecture. That is, if you look on here, we could have said where name equal pencil HB, correct? We could have said that. Or we could have said where quantity equals 0. Or we could have said where price equal 9, all these 9s. We could have done that. Don't do that. If you're ever going to update or you're ever going to delete and you want it to take place on just 1 record and you're using a where clause, always use the primary key field, because that is guaranteed to be unique. It uniquely identifies the record. That's the same definition I gave you earlier. So you should always use that. Even if people, well, you don't have to do that. No, but it's the right thing to do. All right? It's amazing. I can give it an analogy, but it's a terrible one. Because it's like, I don't know about you, but when people get on I-70, I don't think they understand what the speed limit is. All right? Especially when it goes from 65 down to 60. People, for some reason, tend to speed up, not slow down. All right? Okay. So we went through the insert into, and we talked about, we did it in several different ways. If you need more talking or whatever on that, that's in here. I'm not going to go through that. Then we went through and we started talking about select. You know that if you say select star, you get everything. Now, you should only do a select star if indeed you want all of the data. If I'm going through this, if I'm going through the products table and I want to see everything there is about everything, about every product, I should do that. All right? But if all I care about is the product name and the price, that's it, then I shouldn't do a select star. I should say select name, price from products. Okay? And I get less information. The reason that that's important is sometimes people who create databases and people who create tables don't know their butt from a hole in the ground. So what they do is they end up making tables that have way too many fields in them. I've seen these already, 50 fields in a table, which is ridiculous, but people will do it. So now if you say select star and there's 50 fields, it's going to be so wide that you're not going to be able to read it. And if all you care about are 3 or 4 of those fields, that's all you should ask for. It's less taxing on the database server also. You're making it do less work. All right. All right. Again, you can use select without a table. We looked at examples of that. That's not a big thing. You should by now have a good understanding of the comparison operators. In other words, greater than should make sense to you. Greater than or equal to should make sense to you. Less than or equal to should make sense to you. Equal is just a single equal sign. Not equal can be either one of these. I don't care which one you use. If one of those is, you're more comfortable with one than the other, then use that one. You probably already know this, but with the one right here, you can't reverse these. In other words, you can't do a greater than sign first and then a less than sign. It won't work. You can't say an equal sign first and then an exclamation point. It won't work. There's a certain syntax that you have to follow. All right? We went through pattern matching. And if you remember, the percent sign means 0 or more characters. The underscore means exactly 1 character. All right? And we went through several examples of using that. Talked a little bit about the arithmetic operators. These should all make sense to you. You've worked with these. The only one, and we talked about it a little bit, that may not, is div. So if I say 7 div 2, even though the answer is 3.5, it does integer division. So it throws away any decimal. All right? So it's going to give me 3. On some systems, it may give you 4, and it may round up. Okay? All right. Also, by now, you should have an understanding of and of or, and really of, even though it's not shown yet, and of not. Those should make sense to you. The one that's new was this exclusive or. So if again, I know this is review, but this should make sense to you. If I say if x and y, I don't care what x and y are, this must be true. This must be true. Does that make sense? Both sides have to be true. If I change that to or, then either that must be true, or that must be true, or both. Does that make sense? All right. Then finally, there is XOR, which says either this one is true or this one is true, but not both. So with an exclusive OR, only one of them can be true. All right. And not is an inverter. Not true is false, not false is true. Not married is single, not single is married, type of an idea. So all of that stuff by now should be really pretty much second nature to you. The good news is you learned it last semester in JavaScript. It's been reinforced this semester in C#, other than maybe that XOR, and you're using it the same way. If you've noticed too, there's no, you don't use the, for and, a double ampersand. For or, you don't use a double pipe sign. You use the words. SQL, structured query language, is meant to be as English-like as possible. All right? So again, there's the inverter. By now, hopefully this makes sense. That line that you see in blue. And you understand that's a shortcut for saying select star from products where name equal pen red or name equal pen black. That would also work, but this is a shortcut. If we use this and we put not before it, it's going to return all records that are not these two. That should make sense to you because it's doing the inverting. All right? The between and the not between, okay? This right here, let's just look at the first part. Forget about the and. Where they say select star from products where price between 1 and 2. That's a shortcut for saying select star from products where price greater than or equal to 1.0 and price less than or equal to 2.0. All right? The between is all inclusive. So this says include 1.0. If you wanted it to be greater than $1, you'd have to say between 1.01. So $1.01, for example. That should make sense to you. All right? This we haven't talked about much because the examples that they gave us are not good ones for it, but you could run this query and it would come back and it would give you the empty set. Because it says in there, how many records do you have in the products table that do not have a product code in them? They all have a product code in them. All right? But sometimes, and I give this example in the tapes that I was doing today. Let's say that every time you get hired at a company, okay? So let's suppose that all of you are hired at, Acme Widget Company. And when you get hired, you get put into a department, but you're not given a salary until you meet with some kind of a supervisor, okay? So you've got a department, but your salary is null. It's unknown until you meet with your new supervisor. They're going to figure out your salary for whatever reason. So in that case, if we said select star from employees where salary is null, everybody who didn't have a salary yet, they would print out. Does that make sense? And it's not equal null, it's is null. Null is a weird value. Nobody knows what it looks like. You can't compare null with null. Okay? It's just unknown. The order by we did. Remember, when you do the order by, you don't have to put in ASC for ascending. You can put it in, but it's redundant. All right? The order, the DESC, you must use that if you want it in descending order. And you can have as many things that you order by as you want to, need to, have to. All right? And they go from a major to more minor order. So all of that stuff should make sense. We looked at the limit clause. So this would say, just show me the first 2 records. We didn't look at this one, so let's look at this example right here. This is using it with what's called an offset. So this says, skip the first 2 records, but show me the next one. Now you might say, well, why didn't you just ask for the 3rd record? You could do that too. All right? But you can put a range in here. So I can say, start with record 10, show me the next 25 records, for example. Okay? The alias, we did that. So notice that we've changed the names here. So instead of product ID, it says ID. Instead of product code, it says code, etc. Those are the aliases. Now notice they use the backticks. You can use backticks. You can use single quotes. You can use double quotes there. But you can't have a backtick and a single quote. You've got to use 2 of the same. But you can use any of those 3 things. Yes?
When you reorder it or sort it, and then you do the limit, will it do it based off of your new sorting?
The question was, if you sort and then do a limit, what does it do it off of? Well, if limit is the last thing that's in there, it should do it off of the sort. See what I'm saying? So if we do, let's just do it twice. Well, 3 times. Select star from products. So that's everything. Okay? Select star from products. Order by price, let's say in descending order. All right, so we've got that. So let's do it again and say limit 3. Okay?
Oh, you have to leave the order by in there?
It doesn't know otherwise, yeah. When you're doing this, anytime you run a query like this, you get what's called a virtual table. And virtual means it doesn't exist. All right? And just so you know, let's assume I run this all the time. I'm always running this query. That's not a lot to type. I think you'd agree with that, but it's enough. And this is something we'll talk about later, but if I do this, create, view, and let's just call it as. Okay? Now I created something new that's called a view. So now instead of having to type this, select star, instead of having to do all that, I can now just say select star from S, and I get the same thing. So what a view is it's a saved query. So especially if I'm writing really complex queries that are multiple lines long, all right, once I get it to work, I can just say create view, give it a name as, and put all that in there. Boom. Then I have a lot less to type. All right. Not exactly what you asked, but I mean, it was a good time to at least explain that. We looked at the concat, where you could concatenate. In this case, this says I want to concatenate or glue together the product code, followed by a blank space and a hyphen and a blank space, followed by the product name, and I want to call it product description. So that gave you everything that you see here and all the stuff that's in here. That should make sense to all of you. Now, granted, I didn't want to waste your time by doing that. Now, hopefully you didn't find it a waste of time. We're not going to do that every class period. But you should have an understanding of everything we just went over. If you don't, you either have to ask me, all right, or you have to go back and watch the tapes. All right, let's go on. We'll go till about 9 o'clock, and then we'll take a break. So next is producing summary reports. If you'd look up on the screen, please. If you're not already into the system, you can get in the system and run these. If you want to just watch, then just watch. Would you all agree if I did this? If I said select price from products. Would everybody agree, looking at the screen right here, would you agree that there are some repeats? All right. As far as I can tell, at least 125 is in there twice. Don't worry about the 115. I added another record. I changed that thing that was 0 today. I changed it. I was playing around with this stuff. All right. But notice when we say select price, this is what we get. I'm going to run the same query, but instead of price, I'm going to type in distinct price from products. All right. And now we had 7 rows. Now we get 6. What's missing? Here we had 2 125s. Here we only have 1. When you use distinct, it says throw away duplicates. Why is that important? Let's assume that we were creating, we're still going to have that lady come in here from St. Charles County. So let's assume that she wants us to work on something and there's a database component. All right? And they have people, let's say, potentially from all 50 states. Maybe they don't have somebody from Alaska, Hawaii, etc., but they could. And they want to know what states they are actually serving right now. Well, if I say select states from your database, it's going to show me everything, including repeats. If I say select distinct state, it'll only show me one occurrence of each one. You can only use one distinct on a line. So in other words, I can do this. I can say select distinct price, but I can't say select distinct price, comma, distinct quantity. I get an error message. Also because I spelled distinct wrong, but I get an error message because I can only have one distinct. Okay? Now, what if I do this? I'm going to run this in a second, but what if I say select distinct price quantity from products? Notice I got 7 again. And I got 7 because the quantity is different between these two. See that? So quite often when you use distinct, you're only going to be printing out one field. You don't have to, but normally that's the way that it's going to be. All right? And I could do the same thing. Notice in my case here, I've got two things with a quantity of 8,000. So if I said here, select distinct quantity from products, again, instead of 7 rows, I get 6. Now that should make sense to you. All right, as far as what distinct is, how it's used, etc. If it doesn't, take a look on here and run some of these. All right, group by. The examples that they give in here are not great, so I'm going to give you my own. From products. Again, here's all of our information. Okay? Now I'm going to run the same thing, and I'm going to modify this, but I want you to see this. So I'm going to say select star from products, but I'm going to tell it to group by product code. And it gives me, what? That looks a little weird. Well, it's going to lead into something that we're going to talk about after the break. But would you agree, if you look on this, we have 1, 2, 3 pens, and I put this one in there, so don't worry about it. And 1, 2, 3, 4, well, 1, 2, 3 pens, 3 pencils, and one that says Eversharp. Would you agree with that? But if we look over here, we have 3 pen codes and 4 PEC codes. Would you agree with that? All right. Well, there's a command that, again, we're going to talk about this after the break, but if I, instead of saying select star, I'm going to say select count star from products, group by product code. See the difference? Now, that's not very explicit. You know, to say count star for a name, that, I don't know about you, but that confuses me. All right. So I could say in here, okay, I want to run this again, and what I want to do is, instead of count star, what I want to do is I want to select the product code as, we'll call it product code, comma, count star as, again, not a great name, but we'll use it anyway, how many. Thank you. No, it wouldn't have worked, so thank you. All right. And now I'll do that, and I'll say in here, group by product code. It doesn't matter. See what we get now, though? This is the kind of information that you may be asked to provide by a supervisor. All right? Don't ever underestimate the dumb things that people in management will ask you for. And that's not meant to make you smile. It's not even meant to criticize management. But sometimes they don't know what they're looking for, so they'll ask you for stuff that's really goofy. So to go back to what Tiffany said too, just so you know, where we did this, these could have been single quotes. These could have been the backticks. Either of those would have worked. All right? So group by allows you to do some grouping. Okay? We're going to do something early next week. We're going to start creating another database as a class. So we're going to do some work with that one, where I've created 5 or 6 departments and put each one of you into a different department. So we'll be grouping by departments, as an example. You can group by just about anything. But right here, as far as the data that we have, there's really not much stuff here to group by, really, other than product code. But you could group on other things if you wanted to. Okay? When you work with group by, you oftentimes use what are called the aggregate functions. The main aggregate functions are shown right here. So I want to show these to you, then we'll take a break. All right? So, you all seen this already. That's all of our information from our products table, right? Okay? Well, what I want to do is I want to know what the average quantity is in here. Again, yours might be different. It doesn't matter. But what I want to do is I want to add 5,000, 8,000, 2,000, 10,000, 8,000, 15,000, 1,000, then divide it by 1, 2, 3, 4, 5, 6, 7. That makes sense? All right. Well, and I could actually do the math, but to me it's easier to say select AVG, which is average quantity from products. And it tells me when I add all those up and I divide by 7, I get 7,000. Yours will be different because you probably only have 6 records. So let's say we did this and we got some god-awful answer. So instead of even this, 7,000 with 4 decimal places, so let's say you've got like 83.6666667, which is ugly. All right, it's correct, but it's ugly. So what you can do is you can say this and you can tell it, well, I want to round that, what I'm about to do, and I want to round it to 2 decimal places. That looks a little bit nicer. So you can see the difference between the two. All right, round is a built-in SQL function. All right, again, at the end of class, was it yesterday, I guess, 2 days ago, Brady and I were talking right at the end of the class, and he said, because he was having problems with his install, and he said, I'm not really worried about this. It's pretty straightforward. It's just get this from here, and if you want, add some requirements. Yeah, that's what it is. Many people like databases because they're really more straightforward than programming is. All right? Most databases have a programming component where if you want to be able to take this and extend it to do something you can't normally do, you have to add code to it. All right? And databases are also nice because if you become what's called a DBA, which is a database administrator, even at a small company, that usually means 6 figures. Usually means you make at least $100,000. All right? You are oftentimes the most important person at a company because you're in charge of the data. And if you've got a company that's totally got an internet presence and does, it's some guy working out of his garage. If you screw up your data, you might go out of business. All right? If you lose data, you might go out of business. All right? We're going to take a break, but one thing, when I was working at Blackhawk, there used to be a place that was over there. They produced and sold hospital equipment. They were a multi-million-dollar company. They merged with another company that bought them out and moved them out of Janesville. All right, but the point is, the guy who ran their IT department, his name Denny Hanks was his name, or is his name. And I asked him, I brought in about 20 students one day and we took a tour. And he said, any questions? And no one was asking. So I thought, well, okay, I'll start with one. I said, okay, here's a question for you. If for some reason you lost all of your electronic data, okay, just imagine somehow that happened. I said, how long could you guys keep going? All right. He said, well, that's a really interesting question that I've never been asked. He said, I'll tell you what, I'm going to guess 2 weeks, and I'm going to think about it. When we get done with the tour, I'm going to tell you. We got done, and he said 2 days. He said they had millions of dollars that were being paid out, sent to them electronically. And if they lost all those records, people who owed them millions of dollars, they wouldn't know who they were. That's why database administrators, they're called the purveyors of the data. They are in charge of what comes into the system and what goes out of the system. All right, let's take a break. We'll come back at 9:15, please.